So in this video, I'm going to be going over the review problems for Test 2, the test over chapters 4 and 5 on probability and probability distributions. Now, what people often have trouble with is understanding what the question actually is asking for. That's part of what I'm going to be testing you on. Can you understand what it is that I'm actually asking you for? Can you understand the question? Now, I'm not going to try to trick you. I'm going to try to be clear and unambiguous in how I ask you the question, but you do have to read carefully and understand what it is that I'm asking so that you know what rule to use or what calculation to perform to answer that question. So as we go over these review questions, pay attention to how the questions are worded, what kinds of questions they are, and then what rule or formula or procedure we use to answer the questions, depending on whether it's an and question or an or question or what. Number 1, a car rental business has 20 Ford autos, 10 Toyotas, 5 Hondas, and 15 Chevrolets. If a car is chosen at random, what's the probability that it is a Ford? So the probability of it being a Ford would be the number of ways that could happen divided by the total number of possible outcomes. Now, if you add up all of these cars, 20 plus 10 plus 5 plus 15 is 50. So there are 50 cars in all. So the probability that if you pick one of those 50 cars at random, that you get one of the 20 Fords is 20 over 50. Now you can either write it as a fraction, and in lowest terms it would be 2/5, or you can write it as a decimal. If you do 20 divided by 50 or 2 divided by 5 in decimal form, that would be 0.4. B, what is the probability that it is a Ford or a Chevrolet? Notice this is an or question, and these are mutually exclusive. The car that you pick could be a Ford, could be a Chevrolet, but it can't be both of those at the same time. So to answer an or question, we would just add together the separate probabilities. Or, for or probability questions, think addition. So we're adding together the 20 out of 50 Fords plus the 15 out of 50 Chevrolets for a total of 35 out of 50 cars that are either a Ford or a Chevrolet. So the probability is 35 over 50, which is, in decimal form, 0.7. C, what is the probability that it is not a Toyota? Well, we could just add up all the cars that aren't Toyotas, all the non-Toyotas, the 20 Fords, the 5 Hondas, the 15 Chevrolets. Or we could take advantage of the rule for complementary events, which says that the probability of something not happening or not being true is equal to 1 minus the probability that it does happen or is true. So here we could take 1 minus the probability that the car is a Toyota. So 1 minus 10 over 50, and that would be 40 over 50 or 0.8. Question number 2. The probability that a person owns a car is 0.80, that a person owns a boat is 0.30, and that a person owns both a car and a boat is 0.12. Find the probability that a person owns either a car or a boat, or both. So that last section is the question, or the thing that we're trying to find. We're trying to find the probability that a person owns either a car or a boat. And notice that is an or question. To answer or probability questions, we use the addition rules. And this time we have to use addition rule 2 because these are not mutually exclusive. The same person could own both a car and a boat, so those could both be true at the same time. So the rule that we're using says to find the probability of a person owning either a car or a boat, we need to take the probability of owning a car plus the probability of owning a boat minus the probability of both of those things being true, a person owning a car and a boat. We're given what all of those are, so we just take 0.80 plus 0.30 minus 0.12 to get our final answer of 0.98. Number 3. A manufacturing company has 3 factories, X, Y, and Z. The daily output of each is shown here. Notice that each factory makes both TVs and computer monitors. So for example, Factory X makes 180 TVs a day and 60 monitors in a day. And if you add up some of these numbers, there's a total of 650 TVs made at all 3 factories together, and a total of 390 monitors, for a grand total of 1,040 items. That's 240 items from Factory X, plus 520 from Factory Y, plus 280 from Factory Z. Now, on the actual test, I might already give you these totals. They might already be added up for you, or I might not. You might have to add them yourself. So watch out. Pay attention to what's there. You might have to add it together yourself, or it might already be done for you. Now, here come the questions. What is the probability that a randomly selected item is a TV? So look at how many ways that could happen. 650. And then that's out of how many ways you could randomly select an item altogether, which is the 1,040 items that there are in total. So the probability of selecting one of these TVs, if you just select any one of these items, would be 650 over 1,040. And if you divide, that comes out to, and I've got all of these rounded to 3 places after the decimal point, so to the nearest thousandth, that would be 0.625. Question B, what's the probability that a randomly selected item is a monitor or came from Factory Z? There are 2 ways we could do this. One way would be to just go through and count all the items that fit this description. How many ways could we get something that's either a monitor or it came from Factory Z? Well, let's see, there's these 150 TVs from Factory Z. They would count because they came from Factory Z. These 130 computer monitors from Factory Z would count. These 200 computer monitors from Factory Y would count because they're monitors. You just have to be one or the other. And then we've also got these 60 monitors from Factory X. So if we add those all together, that's 540 out of 1,040 in all. So the probability that we get one of these that's either a monitor or it came from Factory Z would be 540 out of 1,040, which is 0.519. The other way we could do this would be using addition rule 2. We could take the probability of it being a monitor, that's 390 out of 1,040, plus the probability of it being from Factory Z, that's 280 out of 1,040, minus the probability that both of those things are true, that it's a monitor and came from Factory Z. That's like counting up all the monitors plus all the Factory Zs, but then subtracting the ones that we counted twice so that everything only gets counted once. So if we do it that way, it's 390 out of 1040 plus 280 out of 1040 minus 130 out of 1040, and that also does come out to be 540 out of 1,040, or 0.519. C, what's the probability that it is a TV and came from Factory Y? Notice the word "and" there. So the only ones that count are the ones that you have to be a TV and you had to come from Factory Y. That's these right here. There are 320 ways that this could happen out of 1,040 in all. So the probability is 320 divided by or over 1,040, which is 0.308. Part D, what's the probability that it came from factory X if it is a monitor? So if it's not a monitor, we don't care about it. We only care about the monitors. So if it's one of those, under that condition, we want to know what's the probability that it came from factory X. So just out of these, there's 60 ways that our item might have come from factory X out of 390 in all. So that probability would be 60 over 390, or 0.154. What's the probability that a randomly selected item is a TV, given that it came from factory Y? So this is another where the condition is that it came from factory Y. So we're only considering the factory Ys. We're given that it came from factory Y, so we don't need to worry about the ones that didn't come from factory Y. But if we know it came from factory Y, what's the probability that it's a TV? Well, how many ways could that happen? 320. Out of how many in all? 520. So the probability is 320 over 520, or 0.615. And what's the probability that it did not come from factory Z? This is another one where there's more than one way we could look at it. We could just directly count up all the ones that fit this description, all the items that did not come from factory Z. That would be these 240 from factory X plus these 520 from factory Y. So 760 out of 1040, or 0.731. Or we could use that rule about complementary events and say the probability that it did not come from factory Z would be 1 minus the probability that it did come from factory Z. So 1 minus 280 over 1040 is 0.731. Okay, question 4. This is not a multi-part question, so this is going to go faster. The probability that Sue will live on campus and buy a new car is 0.37. The probability that she will live on campus is 0.73. Find the probability that she will buy a new car if she lives on campus. So notice what the question is actually saying. Find the probability that something, if something. The probability that she will buy a new car if she lives on campus. So this is one of those conditional probability questions. It's asking us about the probability of one thing being true if something else is true. And the formula for conditional probability says the probability of one thing being true if something else is true is equal to the probability of both things being true, A and B, divided by the probability of the condition being true. So we're given both of those probabilities, we just have to divide. 0.37 divided by 0.73, and that comes out to be 0.507. Okay, the next question's kind of long. It's got more than one part. So I'm going to end this video here and then come back in part 2 and we'll start in on the rest of the review questions. See you then.